Okay, so we're continuing our discussion with solving radical equations, and now we have an equation that's a little bit different than the ones that we started with. In all the problems that we've looked at to this point, the radical was by itself. This time we have something with it. And a really important point that I want you to understand here is that squaring when it's in this format is not helpful. A lot of students try to do that. Most of them tend to make mistakes when they do that. They do some incorrect things. But even if you do it correctly, as we're going to see here, because we're going to do it that way, we're going to try to square both sides right off the bat. But we're going to see that that actually is not helpful. So we begin by squaring both sides. So we raise both sides to the second power. Now what you have to remember, and one of the most common mistakes that I'll see students make, is that exponents do not distribute over multiplication. Exponents do not distribute over multiplication. Or not, sorry. I said that wrong, I apologize. Exponents do not distribute over addition. They actually do distribute over multiplication. Or subtraction. So you can't just square each of those things, and that's the most common mistake people make, is they'll square the thing, they'll get 2x plus 1 plus 16, which is incorrect. Okay, when you square a two-term expression like this, the only way to do it is to multiply it times itself. And on the other side, we can square the 10 and get 100. Alright, and now we start to distribute. Square root times square root. Well, square root times the square root would be that thing squared, but a square root squared just makes it go away. We get 2x plus 1. And then we take that square root times the minus 4. We'll just get minus 4, square root of 2x plus 1. We then take the square root, or now we take the minus 4 times the square root. We'll have another minus 4 square root of 2x plus 1. And then finally, minus 4 times the minus 4 will be plus 16, and then again that's equal to 100. Okay, and then we can see here that I have some like terms that I can combine. Nothing for the 2x to combine with, but I have the 1 and the 16, so I can get 2x plus 17. And then I have these two things. I have minus 4, square root of 2x plus 1, and another minus 4, square root of 2x plus 1. So if I have minus 4 of them and another minus 4 of them, then I have minus 8 of them. And that's equal to 100. And so by squaring both sides, we ran into this. And all I can say about this is that's worse than what we started with. That's horrible looking. Compared to the thing we started with, it's terrible. It's terrible, downright horrible looking. Okay, so what do we do then? What are we going to have to do now? Because squaring it didn't work. It made it worse. Well, the problem that we had was that we tried to square it when it was an addition or subtraction problem, and exponents don't distribute over that. But if we get the square root by itself first, then there won't be any worry of that. And so that's precisely what we do. So we begin by adding 4 to both sides. Now we have the square root of 2x plus 1 is equal to 14. We can proceed to square both sides now. When you square the square root, it goes away. 14 squared would do 196. And then we solve that equation. Subtract 1 from both sides, we get 2x equals 195. Divide by 2, we get x equals 195 over 2. Now this is a radical equation, so we should check that answer. So if you go back to the original equation now, plug in 195 over 2 for x. That would be 2 times 195 over 2. The 2's would cancel out. We get 195 plus 1. 195 plus 1 would be 196. The square root of 196 is 14. 14 minus 4 is in fact equal to 10, and so that answer does in fact work. Okay? So that's the process that we use to solve an equation, and a very important idea. We must get the square root by itself before we square both sides. And again, one of the more common mistakes is when somebody does this is they try to distribute that exponent, and that's wrong. Okay, you cannot distribute exponents over an addition or subtraction problem. Okay, until our next video.